So let's go ahead and talk about that try one more. There's a lot of ways that we could represent this problem, including fraction tiles or a number line, but for this conversation, I want to focus again on a visual model like we did for the problem of the day. So, how could we represent this problem with a visual model? Say it out loud. Yeah, so we're going to draw a model with thirds because we know we're working with a 1/3 measuring cup in the problem. And then we're going to shade 7 of those because there are 7/3 cups of flour that she's used in the recipe. Okay, so then how could we write 7/3 as a mixed number and why? Say it out loud. Yeah, we could actually write it as 2 and 1/3 because we can regroup each of these 3/3 into one whole. So that gives us 2 wholes. And then we'd have 1/3 left over. So when we are converting from a fraction greater than 1, like we have here, right, 7/3, to a mixed number, what do we need to think about? Say it out loud. Yeah, it's helpful to think how many wholes and then how many leftover fractional parts are there in this fraction. Read this with me. Think. How many wholes and how many leftover fractional parts are in this fraction? Okay, last question here. Why is the denominator particularly important when we're rewriting a mixed number as a fraction greater than 1 and vice versa? Say it out loud. Right, that denominator is telling us how many fractional parts are in one whole. And we have to know how many parts are in one whole if we're going to count all the parts to write a mixed number as a fraction greater than 1, or if we're going to regroup fractions as mixed numbers, right? Regroup fractions as whole numbers if we want to actually write the fraction as a mixed number.